All right, so on page 77, we are going to start talking about transformations, okay? The same transformation rules we did in topic 3, the same transformation rules we did with square roots, and the same transformation rules now apply to a log, okay? So, number 1 says, what is the general form of the logarithmic function? I'll write it bigger too so you can see. Y equals A times log base 2 x minus h plus k. So you still have an a value, you still have an h value, and you still have a k value. They all still mean the exact same thing. Okay? So, on the first one, or number 2, I guess, it says, how does the effects of changing the parameter h in the general logarithmic function? Well, you know that when it's inside the parentheses, it's the opposite of what your brain thinks, okay? So, for example, if it says, and this is on number 2, if it says x minus 2, okay, I'm going where? Not up. Right. If it were to say x plus 2, I would be going left. Now, here's why. Here's the general equation, okay? It says x minus h. So remember, you just plug in for the letter, okay? So right here in this first one, this first example, what would h equal? Would it equal 2 or would it equal negative 2? Just 2 because we are just plugging in for the letter, okay? See, if you notice right here, this says x minus h, okay? All right. Now, the other one, if it's going to the left, then it's got to be what kind of number? Going to the left. A negative. So, h is going to be a negative 2. But, in this equation, how did it end up positive? A negative and negative make a positive, okay? Because the original equation has that negative in it. So if you move this h value, when it's a positive h, it's going where? Right? And if it's a negative h, it's going to the left, okay? On, whoops.
You just can't record that too?
Huh?
You just can't record that part too?
Yep. All right, on number 3, it says, what are the effects of A? Okay. A does 2 things. Let me go to the next one. All right. If A is greater than 1, it is vertically stretching. Good. And in this case, it means it becomes steep. Okay? Because it only has one side. If A is between 0 and 1, meaning it's a decimal or it's a fraction, then it is vertically compressed, and it's becoming more what? Flat. Good. Now, if there is a negative in front of that A value, What does that negative sign mean? It does what over the x-axis? It flips or reflects. So if you want to write negative out front equals flip over x-axis.
So technically, there's 246.
I did that better too.
All right. Now, if I put a I can't get to 0, but if it's greater than 1, that curve's becoming what? Vertically straight or steeper. If, Chase, turn around. If it's between 0 and 1, meaning it's a decimal, it's pretty what?
Flat.
It's pretty flat. If it's negative, what do you notice about the line? It reflects. It changes the direction. Okay? All right. Oh, dang.
Pandora got you.
I don't know why it keeps doing that. All right, on the next page, 378, it asks for a K value. K values go up and down. If K is positive, it's going where? Up. And if K is negative, it's going good. Oh, that's not A value. Here's K moving down. Here's K moving up. Okay. All right, flip over to number 6, page 379. Go ahead in your calculator. Go to y equals, like you're going to graph something. And it may already be there. In the first line, the first y, you need to type in, if it's not already there, y equals log base 10 of x. And it may already be there. If it's not, how do I get that log base? I can do 2 things. I can hit math. What? Do what? Math A. Or I can hit alpha window 5. Okay? All right, so once you get log base 10 of x, type in. Tab to the next line below it. And I want you to type in y equals log base 10 x plus 2 and then the third one, y equals log base 10 of x minus 2. Now, notice that those 2's, are they inside the parentheses or outside? They are outside. So those 2's are what type of values? A, H, or K? They're K values, okay? So, on your paper, you've got those 2 functions. What does the first one mean we do? Or this one right here. What does it mean we do? How is it different from where we started, which is right here? It went up to. So on your paper beside that function, I want you to write up to. The one below it says what? -2. So if it's a negative K, it's going. So I'm going to write down 2 underneath that. So once you have all 3 of these typed in, all at the same time, I want you to hit graph. And I want you to sketch that graph on your paper. It should look something like this. B. This time, it says y equals log base 10 x plus 2 and y equals log base 10 x minus 2. So in your y equals, keep that first one. Keep y equals log base 10 of x, because what we're doing is we're comparing these graphs to the original. Okay? What is the first one probably going to do, since it says x plus 2 in the parentheses? Not go up to. Since it's in the parentheses, it's going to be a horizontal shift. Left 2. Because remember, it started out as x minus h. So in order for it to have read x plus something, you have to plug in a negative number. Okay? What about the bottom one? When it says x plus 2 in the parentheses, it's going to the right. All right, I want you to graph those, just like we did before. Make sure your 2 is inside the parentheses. Blue, okay? What's the green graph? What did it do? It went to the left, and the red graph went to the right. Did the arch of it change? Nope. Now, flip over to C. I bet it's going to change too. So the first one we have, keep your original, y equals log base 10 of x. Y equals 2 log base 10 of x. And y equals a negative 2 log base 10 of x. So, in the first one, we've got a 2 out front. Okay? It's It's our A values. When it is greater than 1, what does it mean it's doing? It's being vertically stretched, or it's going to look like it's more steep, okay? So the first one is, we'll just write steep. The second one is doing not just one thing, but it's doing two things. What's that negative out front mean? Flipping over what axis? X. So I have a flip over X, and that 2 also means it's becoming not flat. Just look at the number itself. Compressed and flat are the same. What's the other one? Vertically what?
Straight.
Vertically stretched. So look, here's how you do negatives. You wrote off the negative. You know it means flip over the x-axis. Okay, so you can get rid of that. Now you've got a 2 left. You don't have a negative 2 left. You got a 2 left because you've already wrote off what that negative means. So now you just have a 2. So what's a positive 2 mean? Vertically stretched. Or it means it goes up if it's a K value. Yeah. But A values, it's going to be stretched. So this graph does 2 things. It flips and it stretches. Okay? Or becomes steep, whatever you want to call it. And you'll see it in the graph. Ooh. Oh, Lord. All right, so the blue graph, pretty simple. Okay, that's my original. Look at the green one. That green graph is a little more curved. Okay? The red graph is also curved, except it's curving down where the green graph is curving up. Okay, so that's the difference. All right, go to number 8 on 381. It says, use your knowledge of transformations of the parent function to graph the function y equals log base 2, x plus 2, minus 4. Number 8. All right. First, let's label A, H, and K. All right. What is the A value? Does it have one? If it doesn't have one, it's just 1. All right, H comes next. So is H going to be a positive 2 or a negative 2? Negative. Because, remember the equation is y equals a log base 2 x minus h plus k. So since it's already a negative there, in order for it to show that it's positive right here, you got to know that 2 negatives make a positive, okay? Now, what is my K value? Negative 4. Now, we're going to graph this without a calculator, okay? You know the generic log looks like this, okay? You have a value of negative 2, negative 4. That is your H and K value. It can also be your X and your Y. Okay? So on my graph, I'm going to plot that point. Okay? So draw you an axis on your graph. We start at 0 and we go left 2 times. And up 4 or down 4? Down 4. So 1, 2, 3, 4. So we got a point at -2, -4. All right. Now we just make our log function. We're just sketching it. So you're just making it look something like that. Properties of logs. There are 1, 2, 3, 4, 5, 6, 7. 7 properties. Okay? But if you know your exponent rules, this should be fairly easy. Okay? So, first one, the easiest one there is. Easiest one there is. B to the 0 equals 1. Second one, you should also know. B to the n times B to the m equals. What do you notice about your bases? They're the same. When our bases are the same and we're multiplying, what do I do to my exponents? I add them.
What?
All right?
I think I know how I feel about it too.
B to the n divided by B to the m equals what, Chase?
B, n minus m.
And minus m. All right, and the last, or not the last one, but out of these 4, B to the n, all to the n power. What rule is that? What rule is this?
The power rule.
Power rule. What do you do to your powers? You multiply them. B and nm and the exponent. All right. Now, let's go ahead and write the conversion on there just so we have it. So, B to the y equals x changes to y equals log base b of x. That'll be the 5th. Guess there'll really be 8. All right. Now, you know that b to the 0 equals 1. Okay? We wrote that down in the first one. So I want us to take b to the 0 equals 1, and I want to change it to a log function. Okay? So, what is my y in this case? 0 equals log. What's my base? B of 1. Now, here's a little trick. Any time a log of 1, that's the big number, not the little base, the big number, is 1, then it will always be equal to 0. So, if I have a base of 42, I have a base of 42. It would read you don't have to write this. LOG 42 of 1. Okay? No matter what that base is, if that number in your parentheses, your big number, is 1, it's always going to be equal to what? 0. Every single time. Okay? So maybe under that 6, let's write log of 1 in any base is always equal to 0. Are you writing this down? All right, the next one is also a trick. Let's change b to the 1 equals b to a log. What is my y value in this case? 1 equals log base b of b. What do you notice about your base and your, in this case, letter in parentheses? They're the same. So, if I have a case, let's just say log base 5 of 5. Since those two numbers are equal, every time it's going to equal 1. If I have a log base 78 of 78, it's going to be equal to what? It's going to be equal to 1. When those numbers are the same, equal to 1. If just my big number is 1, no matter what the base is, that log is going to be equal to what? 0. See, I tricked you. You thought I was still talking about the other one. All right. Last one. I'm going to have to erase this because I don't have any room. Is this is I guess the exponent rule of logs. So when you have a log base b, and I'm just going to use p and m to the exponent, okay? You got an exponent up top.
Is this number 8?
Yeah, this is number 8. When you get ready to solve and simplify these logs, what'd I do to my M? Where'd I move it to? Moved it to the very front. So it's in the exponent. And I move it to the front. Okay? So an example would be log base 10 of 7 squared. Okay? I want to change that. Okay? It's the same thing as if I say 2 log base b of 7. Okay? You just move it to the front. If I started on the right side and I had 3 times log base 4 of 9. Okay? And I just didn't want to solve it that way. Log base 4 of 9 raised to what power? To the third power. It's the same thing. Okay? So now, what I want you to do, your rules. So number 1 has 4. Number 2 has just 1. Number 3 has 1, and number 13. And you should be able to use all of the information we just wrote on your note cards to answer correctly. Okay? Number 13 is on page 388 once you get to it. How is 13 true? Thank you. I'm rearranging it. Look at it like this. Let me give you an example. If let's see. All right, let's say you are given log base 3 of 16 equals 2.524. Okay, this is just an example. You don't have to write this. Let's say we're given that. Okay?
Hey, can I see? I'm so sorry.
All right, look. You are given this. Okay? Your problem that you're getting is log base 3 of 256. Okay? Type in 16 squared. Just 16 squared in your calculator. What do you get? 256. Okay. So tell me this. Are these two problems the same thing?
Yep.
Yep. Okay. Now, what do you know that log base 3 of 16 equals? 2.524. That's what you're given. Okay. Now, I want to change. Let's see. I want to change this right here to where the exponent's in front. Okay? 2 times log base 3 of 16. See what I did? What did I do? I just put the 2 in the front. Okay? I want you to type in math. Go all the way down to A. We're going to type in a log base, or if you do alpha window 5, do that. In your base, you're typing in a 3. In your parentheses, you're typing in 256. And you're hitting enter. 5.04? 7? Is it a 7 after? Is that what everybody got? Okay. Now, I want you to type this right here in. The bottom one. 2 times log base 3 of 16.
Is that like an expanded version?
Bottom is an expanded. If I'm squaring something, that's the same thing. If I say 4 squared, how many times am I multiplying those 4s? Is that not what I'm doing right here? This says 16 squared. But if I move it to the front, how many times do I have to multiply that 16? Twice. I don't multiply it by 2. I multiply it 2 times. Okay? So that is how you show 13 is correct. Okay? And after lunch, we will do, going to do 15, A, B, and C. 16A. We're going to do 15, 16, 17, call it. Deal? Won't take us long. Alright, on 15, you will notice that you are given these 2 things. Log base 2 of 5 equals 2.322, and log base 2 of 7 equals 2.807. Okay? So, oops. On the first one, we've got to solve log base 2 of 35. Keep in mind what you're given. How can I make 35 with what I'm given? What times what is 35?
7 times 5.
7 times 5. Okay? So, tell me this. Is log base 2 of 5 times 7 the same thing as log base 2 of 35? Yeah. Because what's 5 times 7? 35. All right. Now, look at your note card. What happens to our logs when we expand them if they're multiplying? What operation do we do? Think about your exponent rules. When you're multiplying, you do what to your exponents?
Add 'em.
You add them. So here, when you're multiplying 2 logs, To expand them, what should I do with 5 and 7?
Down.
Add them, okay? So we've got log base 2 of 5 plus log base 2 of 7. Now, what is log base 2 of 5? It's log base 2 of 5. Look at your directions.
Oh, log base 2 equals 2.32. Something like that.
2.322. That's what you're given, okay? Plus, what does it say log base 2 of 7 equals? 2.807. So what do you do with those two numbers? When you add them, you get 5.129. Okay? Now, to make sure we're correct, go back in and type what I've starred. Log base 2 of 35 using Math A or Alpha Window 5. What is different about B from A? It's dividing, okay? So, now, I want you to try B on your own. Instead of adding those logs and I expand them, what should I do? I should subtract them. What is the first log equal to? 2.322 minus, what's the second log equal to? All right, when I subtract those, do I get a positive number or a negative number? I get negative. Negative point. Did everybody get negative 0.485? If you go back in and plug in the original log, do you get the same thing? Have you done that yet? Okay, get the same thing. Now, C is one like we did right before lunch. We've got log base 2 of 25. Based on what you're given, how can I split up 25? 5 times 5. So I've got log base 2 of 5 squared. That just means 5 times 5. What's 5 squared? 25. Okay. Now, what must I do with that exponent? Bring it to the front. So now I have 2 times log base 2 of 5. But what do you know log base 2 of 5 equals?
Log
2.322. So when I multiply those two things, 4.644. Does that one make sense? All right. Here is 16 on the next page. On the top of that log, I'm multiplying. Then I got some division. So I've got to add and subtract some things. Okay? So, first, log base 3x plus 4 cubed. What are the top two things doing? Are they multiplying, dividing, adding, or subtracting? They're multiplying. So what do we do when we multiply? Add. Alright, so we have log 3x plus 4 is cubed plus log 2x plus 7. Oh, thank you. Minus 7. Now, since that 4x minus 5 is on the bottom, what operation am I going to do next? Okay, it is dividing. It is dividing. But what do you do when you divide? You subtract. So we're going to subtract log 4x minus 5. So we're adding the two things on the top because they're multiplying. We are subtracting what's on the bottom because it's in the bottom of the division. Okay? Now, there's one more thing I can do to simplify this all the way down. What is that one thing? Look at my exponents. Not multiply, not square. Not cube root, but the cube. What do you do with that 3? Think about the rule we just did. The exponents go to the front. They move to the left. They go to the front. So we've got 3 times log of 3x plus 4 plus log of 2x minus 7 minus log of 4x minus 5. That's as far as we can go to simplify. Okay? But look at all of the problems on page 390. None of them have a what? They don't have a base. Okay? And this teaches later on in this section, but it really needs to be taught now. So, when something in my eye. When you see a log and it has no base, okay? It's understood as log base 10. For example, if I write x plus 4 equals 0. Okay? Linear equation. Is that the same thing as me saying 1x plus 4 equals 0?
Yes.
Yes. Okay? So, for any equation other than a log, it's understood as 1 if it's not there. However, When a log is missing something, the base, and it just says log of, let's just say 3x. Those are the same thing. Okay. So, if you have room on your note card, maybe on the back or wherever, I want you to write if there is no base present, the base is understood as 10. And then attach this example with it that I've drawn an arrow to. Number 17, we can only simplify all of these. So, the first one says log, it doesn't have a base, so we just know it's base what? Base 10. And you don't even have to write the 10. You can if you want to, but you don't even have to. 6x squared over y. Okay? First, it's dividing. Okay? When we divide, what do we do with our numerator and our denominator? What operation? We subtract. Okay? So first we're going to say log 6x squared minus log of y. Okay? Now, what are the 6 and the x squared doing? They are multiplying. So we can split those up and expand them. Since they're multiplying, what can I do with log 6 and log x squared?
Move to the front.
We will eventually, but not yet. 6 and x squared are multiplying together. They're right beside each other. What do you do when the two things are multiplying?
Add.
We add them. What did you say? Okay. We add them. Log 6 plus log x squared. And we can't simplify log y anymore. Now, Chase, what can I do?
Move the exponents.
Move the exponent. Good. So we have a log 6 plus 2 log x minus log y. All right, the next one's really easy. You do one thing. What is the exponent? 2x. So what are you going to do to 2x? Move to the front. So you go from log 3, 2x, to 2x times log 3. And that's all you can do.